Hi guys, this is Kumar, and today we'll be talking about upstream and downstream questions. Okay, so for example, look at this question. We have that a ship is basically using 9 hours to travel 80 kilometers downstream and 48 kilometers upstream. But if we change the distances, for example, if it travels 60 kilometers downstream and 96 kilometers upstream, now it is taking 12 hours. So, what is the speed of the ship? So, to solve this question, first of all, it is very important to understand what is downstream and what is upstream. So, basically, if I have the river flowing in this direction and the ship is also moving in this direction, this is a scenario where we take the downstream side of the equation. However, if we have the opposite case, for example, the river is moving in this direction, however, the ship is moving in this direction, or the ship is moving against the current, then we call it an upstream equation. Okay, so the two factors that are relevant in calculating the downstream and the upstream speeds are basically the speed of the ship, let's say that is x, and the speed of the river, let's say that is y. In upstream case, the ship is traveling against the river. Okay, so what happens, its relative speed to the ground gets reduced by the value of the speed of the river. In the other scenario, when we have the downstream speed, what happens is this the relative speed of the ship to the ground basically is nothing but x plus y. Okay. Now what we do if we have to find the equation for total time, like we have here for 9 hours it takes for 80 kilometer downstream and 48 kilometer upstream. What we have to do is basically we have to start with some upstream distance by upstream speed. And to calculate downstream time, we'll have the downstream distance divided by the downstream speed. All right. Okay, so let's see how these two equations come about. So the first scenario, we had 80 kilometers being traveled downstream, so that has to be divided by the speed of the downstream speed, and 48 kilometers upstream, so that is divided by x minus y. Now this is coming out to be around 9. In the second scenario, we have 60 kilometer being traveled downstream and 96 kilometer being traveled upstream, and the total time comes around to be 12. Now you have to understand that we have two unknown variables, right? Which are x and y. Of this, x is of our particular interest because we've been asked to calculate that. We also have two equations in terms of x and y. Okay, so what you can do is you could simplify and find out the value of x and y, but it would be a little complicated. So a better solution to this, or a better method to solve this kind of question, is by using dummy variables. Let's see how to do that. For example, what we'll do is that this x 1 by x plus y will take as u, and 1 by x minus y will take as v. So the equation becomes 80u plus 48v equal to 9, and 6, and for the second case it will become 60u plus 96v equal to 12. Okay, now this is straight away simultaneous equations. It is much easier to solve and easy much simpler to look at, right? What we can do is, after we find the value of u and v from these two simultaneous equations, we could take the reciprocals and we'll get the value of x plus y and x minus y. When we have these two values, we could just add up them and get the value of 2x. So this is my plan. Okay, so yeah, it is very important that before starting the question you have a certain plan. The use of dummy variable is a tool, it helps you do the question, but having a straightforward plan of how you want to get the answer is very important. So you need to develop this. So let's start by finding the value of u and v. Okay, so for solving u and v, it is very basically what we are trying to do is we are solving simultaneous equations. So one of the important things we do is we try to make the coefficient of one of the variables same in both the equation so that we can cancel it out by subtracting one equation from another. Okay. uh See, basically, if I have to solve these equations, there are a lot of ways, right? But what if I can make these coefficients equal, right? In that case, if I subtract, let's say this is equation 3 and this is equation 4. If I make the coefficient equal and I subtract equation 4 from equation 3, my u one variable will get cancelled out, so I'll have only one variable left. So this is how you solve a simultaneous equation, right? One of the one of the ways of making the coefficients equal is to just divide this whole equation by the coefficient of u. So if I divide this equation 3 by 80, this coefficient will become 1, and if I divide this equation by 60, this coefficient will become 1. Let's see how it works out on the next page. So I have 80u plus 48v equal to 9, right? I'll divide this whole equation by 80. So I'll have a u plus 48 by 80v equal to 9 by 80. Now let me simplify the coefficient of v. You see the numerator and the denominator both are multiples of 16. I can cancel that out. So I'll get a u into 3 by 5v equal to 9 by 80. Okay. This I'll call as my equation 5. Okay. And for the second case, I have 60u plus 96v equal to 12. What I'll do, I'll divide this whole equation by 60. So I'll have u plus 96 by 60 v equal to 12 by 60. I'll simplify the coefficient of v and I'll simplify our constant. So this will become u plus 8v by 5. Yeah, 8v by 5 equal to 1 by 5. Let me call this equation C. Now you see, in both the cases, the coefficient of u is 1, which means if I subtract one equation from the another, I will get the value of v. Alright. So what I'll do, I'll subtract equation 5 from 6. Okay. Now what happens when I do that? I had u plus 8 by 5v equal to 1 by 5 and u plus 3 by 5v equal to, how much was it? 9 by 80. If I subtract, this will get cancelled out. I'll have 8 minus 3 by 5v equal to 1 by 5 minus 9 by 80. Alright. Now this will become 5v by 5 and this will be 80 16 minus 9. So this gets cancelled out. So v I've got as 7 by 80. Alright. Okay. Now to find the value of u, it's not difficult. I just have to take one of the two equations. Okay. For example, I take the first equation. I have u plus 3 by 5v equal to 9 by 80, which means u is nothing but 9 by 80 minus 3 by 5v. Let me put the value of v. Okay. So this is 3 by 5 into v is 7 by 80. Now we are seeing that there is a 1 by 80 common in the denominator. We can obviously take that out. I'm left with 9 minus 3 into 7, 21 by 5. Okay. So this used to be 180 into, take the denominator common, 45 minus 21 by 5. This is equal to 1 by 80 into 24 by 5. Now I have, what do I have? I can take 8. Yeah, my 8 is a common multiple of both of them, so I can simplify more. This can be 3 by 10 into 5, which is 50. Okay. So I've got two value. I've got my values of u and I've got my values of v. Let me put it here. Okay. So I've got u as 3 by 50 and I've got my v as 7 by 80. All right. So what is next? Okay. Now remember we had taken u and v as dummy variables. All right. And our main purpose is to find the value of x minus y and x plus y. Okay. If you remember properly, we have taken u as 1 by x minus 1 by x plus y. All right. Which means our x plus 1 by x plus y is nothing but 3 by 50, and therefore our x plus y is 50 over 3. Alright. Okay. Similarly, we can do for our v. V was 1 by x minus y, which was 7 over 80. Therefore, x minus y is nothing but 80 over 7. Okay. So, see, this is my equation number 7 and this is my equation number 8. Now to find the value of x, the x that we have been looking from the starting, the speed of the ship, which we had taken as x, we just have to add equation 7 and 8. If you do that, you can easily see I have x plus y as 50 by 3 and x minus y as 80 by 7. If I add those two, my y gets cancelled immediately. So I have 2x equal to 50 by 3 plus 80 by 7. If you simplify by making the denominator same, this will become, the denominator will become 21. You will have 350 plus 240. This comes around to be 590 by 21. And therefore my x is equal to 590 by 42. Okay, this is in kilometers per hour. Okay, so what we have done is we have found out the value of x. Now this is nothing but 590 by 42. All right, so the value that we are getting is 14.04 kilometers per hour. This is the speed of the ship that we have been looking for from the starting. We can also calculate the value of y, right? We had x plus y is 50 by 3, which is nothing but 16.67. So y becomes equal to 16.67 minus 14.04, which comes out to be around 2.63 kilometer per hour. So this is how you will solve upstream and downstream questions. You'll find the speed of the ship and the speed of the river. So hope you have understood how to solve simultaneous equation and how to apply them in downstream and upstream questions. Our final answer comes out to be 14.04 kilometers per hour. This is the speed of the ship. Okay guys, hope you were able to understand properly. Have a good time. Thank you and a happy new year.